Hi guys, Tin Man here. Simple one for you to try at home. Told 49 I was going to give it a shot, see if I could make it a little bit easier. It's been successful. Of course, doesn't have the power output that that one has, but it's a lot easier to make. And that's a little LAG. The core I made from an E-core out of a transformer. I cut out the marked out bits to make a T-core. Put a couple of retainers on it. The run coil is trigger windings on first, as that's how I do them. How many turns? No idea. She was a quick throw to give a job. Probably 250, 300 maybe of 0.33. Over the top 0.71, and I just filled up the coil so it was nearly level with the retainers. On the other side I've just slid a microwave oven fan motor coil on there. I'm surprised it does anything at all because it's about 109 ohms across that coil and the wire is tiny on it. So as rough as it was, I threw it together, and to my surprise this thing runs really sweet, about 52 milliamps. Now one of the reasons it's doing that because I'm using my single battery Bedini circuit. They're coming out of the collector through the diodes straight back into the capacitor. Now I've got 3 diodes on there, you only need one. From the positive of the capacitor into your run coil, and that way a single battery most certainly can be used. Our supply power is from that battery. From that battery we go through our meter, and from our meter to the coil. At the moment, in that crappy little microwave oven coil, which you can see is half the size of that one, the 2 coils should be the same size, and the results will be much better. But anyway, we're getting 5.9 volts out of it, AC, at the moment. We come from these 2 points. Now that we've checked that, I'll get that out the road. And I will show you at the end. I've switched the motor off, put the meter back up there, and you can see it was actually generated voltage, not just coming from the pulse in the coil and working like a transformer. So we're going to come out of them into the voltage doubler. As you can see, it's 2 caps short. I needed one for there, and the other one's over there having a holiday. So in our voltage doubler, in there at the moment, it's 0.4 of a volt. Now I've still got it hooked up to this big 12 volt LED from an automobile. I'm very surprised that thing even contemplates lighting it, but it does. It's dull, but it lights it. So the other thing we'll check as we do is our RPM, and we're doing 1425 roughly. Okay, 52 milliamp draw on our battery. So now we'll hook up our caps. As you can see, the voltage slowly starts to climb. That's how little power that coil's got. It's taken that long to fill the caps up. Around 7 volts, the lights start to glow. You can see they're starting to come on. Keeping in mind, this is a direct DC load to that light, it's not pulsed, so it is a stable, steady load, and it's running that at 8.18 volts, 19. Everything's still ticking away here nicely, and there's the ampere on the motor, same as what we started with. Looking up and down. So there you go. So the next thing we're going to do, measure RPM again. We're now doing 1464 RPMs. So we've gained in RPM. We've gained some power out of that little coil, to run our light, which is oversized for the job. Motor's running sweet with more power RPM as we said, and we're drawing the same current as we started with. So all that said and done, just to show you that the lens forces will still be at work, we will disconnect our motor altogether. Right, no negative hooked on anywhere. Take it off the emitter as well, and we will stop the motor from turning. As you see, it won't go. So we grab our meter back. Sorry about the shaky video, but holding it by hand, these things happen. Okay, we set on our AC voltage, as you can see. We spin the wheel. There you go. Working as a normal generator. The lens forces are there, and this system does counteract those forces and neutralise them. An easy one you can try for yourself. Just use your normal run coil that you got for your machine already, chuck a block in the middle of it, put another coil the other size, preferably the same size, give it a whirl yourself. Cheers from the Tin Man.